Okay, assalamu alaikum guys. Good morning. Welcome back to grade 11 Maths by Inspired Teens. Okay, in today's lesson, we are going to be continuing with Euclidean geometry. Okay, cool. Hope you guys had a good week. Okay, I know we are probably very behind in terms of your guys' schedule or what you're busy with in school. Most of you have probably like started calculus by now. But yeah, we're planning on, no, actually, sorry, this is not grade 12. I take that back. Functions. You guys are probably busy with functions, analytical functions, maybe done with analytical, starting with functions, or even done with all. Okay, but we're gonna get there, right? Hopefully, we're still figuring it out. And like, let's just say we're still behind. Let's hope, like in the holidays, we can do a little bit of like a few lessons to just catch up, so that by term 3 you guys are on par. Okay, that's the plan. But just bear with me. Okay. But nevertheless, let's continue. Before we continue with the other 3 questions, I just want to do one more concept, which I've added here. Okay. Hopefully you guys have been practicing Euclidean and that you guys understand the concepts. Please rewatch the videos a few times, 1 or 2 times, if you don't understand the concept, or if you want to relearn the concept, or if you want to revise the concepts, because that's, like I keep saying, that's a very important part of the section. It's a very difficult, confusing section. So if you don't understand the basics properly and thoroughly, then the complicated stuff are not going to come, right? Because you're not going to be able to understand it because your basics are flawed. Okay, you have to make sure you understand those properly. Okay, so talking about basics, let's discuss one more thing, and it's with regards to isosceles triangles. Okay, so here we have 2 circles. Okay, we're going to discuss it in the first one first, and then we'll discuss the second one. But let's have a look here, right? Actually, yeah, okay, we'll get there. So in this case, right, we have a circle. I hope that we know that. And we have 2 lines drawn in, which are actually radii. So what does that mean? That means that line OA is equal to line OB. Okay, just simply because they are both radii, they are both a radius of the circle. Okay, so radii are equal. It's the distance from the center to the circumference. So therefore, this is equal. Okay, I could draw many other radii and they would all be equal to one another. Okay, so just keep that in mind. But working with these 2 specifically, right, this in the circle, when I complete this triangle OAB, okay, so I draw in the third side AB, now I formed a triangle, more specifically an isosceles triangle, because in an isosceles triangle, we have 2 sides that are equal to one another, and you should remember, correspondingly, we have 2 angles that are equal to one another. So that's very important, okay, because which 2 angles are equal to one another? This is very commonly used in Euclidean geometry, whether it's in terms of circles or not in terms of circles. Here we have side OA equal to side OB. The angles that are equal to one another would be the angles which are opposite to these equal sides. So the angle opposite OB and the angle opposite OA. These 2 angles would be equal to one another. So this angle here, if this angle is X, then this angle here is also equal to X because they're equal to one another. Okay, so just keep that in mind. So in this case, right, we're forming an isosceles triangle using radii. Again, a very common example. However, like, this is not limited to a triangle. Sometimes, and I'll draw in this case, what happens is we have a tangent, right? If you remember the rule of tangent drawn from common point. Okay, I'm going to probably erase this, but I'm just giving you an example of how this could not be used in a triangle, right? You need to understand this in a general sense as well, right? If you remember correctly, the rules for this is tangent from a common point. So you can see that if it is given that at A, this line forms a tangent, and at B, that line forms a tangent, okay, you can see that these tangents, they come from the common point here, okay? And in that case, the rule is that this line is equal to this line. Okay, and you can use the same ruling here. We have isosceles triangle. Now in previous grades, perhaps you've used that as a reason, but we cannot in this case. I'll give you the exact reason that we use. But here in this case, right, we have this angle equal to this angle. Let's label this point C. Okay, so we have side BC is equal to side AC, which then results in the opposite angles being equal, which, like, you have isosceles triangle, 2 angles are equal, 2 sides are equal, which results in 2 angles being equal. Okay, which angles we talk about? We talk about the angles opposite those equal sides. So the angle opposite AC, we'll call this theta, would be equal to the angle opposite BC. We'll call this theta as well because they're equal. Okay. Okay, so I'll just leave it there. It's fine. Okay, so I hope that makes sense. Okay, so these are sides which are equal in an isosceles triangle, two sides in a triangle being equal. And we conclude from that that the angles opposite those equal sides are also equal to one another. So in this case, right, if we refer just back to this triangle from the circle, we have two radii, okay, there and there, and the triangle is completed. So this automatically, you should see it very fast. Those two angles would definitely be equal because they are the angles opposite equal sides. And that's exactly what our reasoning for this guy is. Okay, our reasoning here is angles opposite equal sides. We don't say our reason is isosceles triangle. That is not true. No, it's true, but we're not babies anymore. We use this reason. Okay, so for this specific one, angles opposite equal sides. Okay, and of course, for everything, there is a converse. So the converse for this is, actually, I need to get rid of this. Maybe let's just, okay, we can, let's move it and then we can bring it back. Okay, the converse for this is if we have a triangle, okay, a regular triangle, okay, not in a circle, okay, and in this case, you are given that in this triangle, this angle, let's give it an actual value, right? Let's just say this angle is 30, and this angle is also 30. Okay, so we can clearly see that these two angles are equal to one another. Okay, so it's the converse of this, right? Because here you are given the angles are equal to one another. So since two angles in a triangle are equal to one another, right? You have two angles, you should understand, okay, this is an isosceles triangle, which means that the sides which are opposite to the equal angles are also equal. So this is different. It's not, you don't initially have the sides, you initially have the angles in this case. Okay, but it works both ways. The reasoning is just slightly different. So in this one, what would you say? You would say sides opposite equal angles. Okay, so slightly different. In the first one, what are we saying? We are saying angles opposite equal sides. Here we are saying sides opposite equal angles. Okay, so this you can conclude that this is equal to that. Okay, we don't have to put the circle there, but because obviously in a circle, if it's the radii that are the sides, that's easy to conclude. It's easy to conclude that the sides are equal because they both radii. But in this case, we cannot confirm that this is equal to this, okay? Just like that, okay? However, utilizing this reason that we have equal angles, we can say that the angles, the sides opposite those equal angles are also equal to one another. Okay, so let's maybe write out something. Let's call this A, B, C. We can say since angle B is equal to angle C, which is 30. Okay, we can conclude that side AB is equal to side AC with this reason. Okay, so just keep that in mind. That's what I mean by these two diagrams. Okay, cool. So I hope that makes sense. Please keep that in mind. That's the last theorem we needed to discuss. So let's have a look at this example. Again, we're just going to let's just quickly go through these simple examples, just again to sort of get some practice on the concepts, right? And then we can go through some more hectic questions. We're probably going to spend another lesson on this just to do like another solid example on it. Okay, let's see. Okay, let's have a look at this question. They want us to determine the values of X and Y. Okay, so we mainly in Euclidean geometry, we work with our diagram only, right? So if there was information given, like a description, every single part of that information we want to translate and put it inside of the diagram. Okay, here we just have a diagram as you will have in a few cases, right? So let's see, they want us to determine the value of X and Y. Here's X, okay, here's Y, okay, and here's 88, right? The only value we have. So we're gonna have to try and work around it, okay? So ideally, what I would do if we were in a class physically, I would ask you guys um to tell me like what can we do, right? Well, obviously, yeah, we need to start now. We need to start working with the angles that we have, whether it's variables, whether it's actual values, and just get other angles because of that specific one that we know, right? Using the laws that we know, right? All of it, like all of this information that we just learned above, just combining all of that knowledge and trying to use it. Yeah. So what I'm going to do instead of doing that, I'll just give you guys like a minute. I'm sure you guys have been looking at it already, ignoring me, just talking. But just I'm going to give you a minute to just look at it so that when I solve it, maybe you'll say, okay, I did see that. All right. Okay. So just have a look at it, see what you could potentially do. Okay, not a minute, but I'm sure you guys have had a good look at it. Let's solve it, right? So the first thing that I can see is the rule that we just learned, okay? Because we have a center here, okay? It wasn't explicitly mentioned in the question, but it's fine. Because we have a center here, we have this, we have this, we have this, and we have this, all being radii. Okay, that's one of the first things you should always identify. I have like some rules and like some basic steps for that you guys to follow, but I will refine them. And one of the things that I'll add to them is always look out for equal radii. Okay, so 1, 2, 3, 4 are all equal, so that when we have a potential isosceles triangle, okay, right, we can use that okay, we can keep this in actually. We can use the fact that the angles opposite those equal sides would be equal, and that's exactly what I'm going to do here, right? I'm going to say that this guy is also equal to x. Okay, so that's the first thing I'm going to say. I'm going to say in triangle BOC, okay, angle C is equal to angle B, which is equal to x. The reason, okay, firstly, we don't do that. We first have to say what? That OB is equal to OC. And the reason for that is they are radii. And thereafter, we can conclude that those angles are equal, because now that we've proven that this side is equal to that side, or given a reason for it, now we can say that C is equal to B. Why? We can call this angles opposite equal sides. Okay, this is where we use this reason, because from the sides that we have, we prove that the angles are also equal. So this guy is X, right? So one more thing, actually, sorry to go back. But one more thing you should also be able to conclude from this is the third angle, you can always get it in terms of X, right? Because remember, sum of angles in a triangle, you could simply say 180 minus X minus X. So this is 180 degrees minus 2x. So in an isosceles triangle, it's always going to be 180 degrees minus 2 times the value of one of those angles. Okay. So therefore, this here, okay, I can express this guy in terms of x. Okay, this is going to be 180 degrees minus 2x. So I'm going to say that now. So I'm going to say angle. So we're still in triangle BOC. So I can say angle O or angle O3 specifically. Angle O3 is equal to 180 degrees minus x. And my reason for this is sum of angles in a triangle. Okay, so therefore angle O3 is equal to 180 degrees minus 2x. Okay, and actually before I solve that, right, what I also saw was straight line angles. Okay, this is not going to work with us. Let's just highlight it. This straight line. Okay. Okay, this straight line here, I can use angle O, I believe that's angle O4, this one with 88, and I can get the value of O3 because I can use angles on a straight line and they should add up to 180 degrees, right? So now obviously we're not working in that triangle anymore. I say angle O3 plus, I'm just going to call it angle O4, should be equal to 180 degrees. And I can give my reason for that, angles on a straight line. Okay, and this would be me solving for O3. So I can say O3 is equal to 180 degrees minus O4, which is 88. And that gives me angle O3 having a value of 92. Okay, so now I've solved for angle O3 in terms of x, and I've solved for angle O3 in terms of a value. I know that O3 is equal to 92. So this should be equal to 92. Okay, the entire angle is expressed in terms of x, 180 minus 2x is equal to 92. Okay, this is just one approach to solving it. What you could have also done was solve for O3 first, right? Get a value for O3, say that this is 92, and then solve for x respectively, right? That might be a bit easier, but nevertheless, I just saw this one first just because we just did that theorem. Okay, so in this case, I'm going to say 180 minus 2x, you can just say O3 is equal to 180 minus 2x, which is equal to 92 degrees. Okay, solve for it here. You're going to get 180 minus 92 is equal to 2x. 88 over 2 is equal to x. X is equal to 44. Let's just double check that. 180 minus 92 divided by 2, correct. Okay, so x is equal to 44. So I've solved for x. Okay. So x is 44, right? So if you want, instead of writing x there, you can maybe write 44. Okay, so x is done, x is solved for. Okay, just another thing to keep in mind. This here is not a cyclic quad for now. Okay, we could potentially prove it in the future, but right now, as it is, this to us is not a cyclic quad because it is not drawn within a circle, right? So please don't assume that that's a cyclic quad. Right, remember a cyclic quadrilateral, all four vertices, all four corners of the quadrilateral has to be touching the circumference of the circle. Okay, so just keep that in mind. This is not a cyclic quadrilateral. Okay, okay, that being said, let us try and solve for y. Okay, so let's just see what's the ways that we could solve for y. So I used angles around the point because O1 is equal to O3. Okay, that's a good one. Okay, so O1 is equal to O3. So this is also equal to 92. Of course, I'm not going to write in terms of x because what's the use? I can just write its value. That's 92. Okay, so O1 is equal to 92. Okay, I want you guys to actually help me here. Tell me, what do we think? How could we solve this? Okay, because we cannot use cyclic quadrilateral, right? We cannot use our radii right now because there's no triangle drawn in, like triangle ADO. Okay, we have angle O1. However, that's the only thing we have for now. No parallel lines are given, so we can't use fun. I'm just trying to think. Y is equal to, well, y equal to 184. No, it won't. What's your reasoning? Tell me your reasoning. Why did you get to 184? Yeah, even if you don't give me the answer, I just want a way. Well, how do you think we could solve this? Angle at center is equal to 2 times angle at circumference. Okay, so that's good. Okay, however, it's not correct. So that is the approach that we're going to take. We are going to use angle at center is equal to angle at circumference. Okay, so I hope a few of you are saying oh, like oh, and seeing how it is. This is a tough one, right? This is the confusing example of angle at center and angle at circumference. It's not the straightforward example, right? Let's just quickly revise it. So remember we said angle at center, angle at circumference. If I drew it like this, okay, this is very easy to see because I can clearly see that one is the center angle, again from the same chord, and one is the circumference angle from the same chord. But what happens when it's drawn like this? Okay, now it's a different story. Now it's a different story. Why? Because this is a lot more confusing to look at. Okay, angles at center and angle at circumference. Okay, so here these are both angles which are subtended by chord DA from this example. What is that? That's E, that's O. Okay, these are both angles, angle E and angle O1. Angle O1 is here. These are both angles subtended by angle DA. However, they are not in the same segment. Now, if you remember correctly, we have two different possibilities, and let's go back to our theorem. Okay, so we had this basic example. Okay, angle at center is equal to 2 times angle at circumference. This weird example where the angle at the circumference is created by the diameter, so it kind of doesn't look like they come from the same chord, but they actually do. Okay, that's another confusing example. Then we get this guy. Angle at center is equal to 2 times angle at circumference. However, what happens when the circumference angle and the center angle are not in the same segment? That's when we have to work with our reflex angle at the center. Okay, if the circumference angle is in the other segment, okay, remember each what do you call these things? Each chord separates the circle into two segments. One is this guy, and the other one is this one here at the bottom. Okay, two different segments. So when the circumference angle is subtended in the same segment, that's okay, right? Then we just multiply, we divide this by 2 to get the circumference angle. So this angle would be equal to x. But when that's not the case, again, it's in the different segment. So the circumference angle subtended by the same chord AB, but it's not in the same segment. This is in the bottom segment, this angle here, theta. That's when we find the reflex angle at O, okay, and we half that to get the circumference angle in the other segment. Okay, so yeah, in this case, again, this is it's the same thing in our question, just obviously not drawn with the same orientation. This one is sideways, which makes it like even more difficult to see at times, unfortunately. But yeah, that's basically the concept we're following. So we have O1 as 92. Okay, so the reflex angle, okay, and also nothing's going to prevent you from being able to draw another diagram like this. Okay, so don't feel shy, even in the paper, to like redraw your diagram roughly just to solve like one question, right? You don't want to like put too much jumbles there. Okay, so this reflex angle is going to be 360 minus 90. Okay, so the reflex angle is going to be, sorry, 92. So the reflex angle is going to be equal to 268 degrees. So the reflex angle at center is equal to 268 degrees. So the circumference angle in the other segment is going to be equal to half of that, because angle at center is equal to 2 times angle at circumference. So I divide that by 2 to get this angle of 134. Okay, so I hope that makes sense. Please, if you have any questions or if that's confusing, let me know, then I can go through it again. Either way, I'm just going to revise it in the main diagram one more time. So this is the circumference angle, and it's equal to 360 degrees minus 92, which gave us 268. Okay, and then we found y. So let's do that with reasons. I'm going to say I'm going to label it angle OAD, but it's the reflex angle. So you can label it angle O1, reflex O1. Okay, reflex O1 is equal to 360 degrees minus O1. The reason for this is angles around a point. Okay, so therefore this is equal to 360 degrees minus 92, which is equal to 268 degrees. Okay, then we can say what is this angle? Angle E or angle OY. Angle E is equal to a half times reflex O1. Okay, and the reason for this is angles at center equals 2 times angles at circumference. Okay, there's no need to say there's no need to say there's no need to like give any of the reason in the other segment or anything, though that was just for your understanding. Here, this is enough. Saying angles at center is equal to 2 times angle at circumference, right? And halving the reflex angle. So this is equal to half times 268. So angle E is equal to 134 degrees Celsius. Okay, not Celsius, obviously, but basically, therefore, y is equal to 134 degrees. So we solve for y. Here we solve for x. Therefore, x is equal to 44. Okay, so I hope that makes sense. Done, question done with reasons and everything. Okay, someone asks, why don't we subtract the 88? Because okay, let's have a look at this, right? Why don't we subtract the 88? Because here is the angle at center that we're working with, right? Let's consider what is the chord we're working with. We're working with chord AD. Okay, so since we're working with chord AD, O1 is the center angle that it subtends. Okay, it creates angle O1 at the center. Okay, so therefore, the center angle that we're working with is O1. The reflex angle is what? The reflex angle is everything besides that angle. So the angle around the point, okay, which is basically then this angle here that we work with. Let's maybe do it like this. Okay, so what I can do is I can say 360 minus 88 minus 03 minus 02. This is going to give me the reflex angle at O1. However, I don't need to do that because I have the value of O1. Okay, so what I can simply do is I can say 360, because remember, all of this, I'm going to do it in pink, all of this is equal to 360, and this part of it is equal to 92, which is this part here. This part is 92. So then this part is going to be the whole thing minus 92. So therefore, that's when I say 360 degrees minus 92 to get the reflex angle. That's why I'm not subtracting 88. Okay, because there's no need. Or yeah, you could also, if you add this and that, then you can simply just add those three to get your angle, but we don't. And there's, yeah, you could, we actually do. Like this is 92, this is 88, right? So you'll see we'll get the same answer if you say 88 plus 92 plus 88 again, right? Yeah, if you add these up, you'll get 268. Okay, so you could do that as well. Alternatively, you could say 360 minus 92, all angles around the point. Okay, and then once you get that reflex angle, remember that the reflex angle is double. It's the center angle that's double. Let's say this is 268, this whole thing. It's the center angle that's double of the circumference angle in the other segment. Okay, let us move on. Let's move this. Okay, and let's do this example now. Sorry, one more thing. Okay. In this circle O with diameter AC, AD, AC and DC equal to AD, and B2 is equal to 56 degrees, determine the size of DAB. Okay, so none of this information is translated over into the diagram, so let's do it. They say that diameter AC, so if the diameter is AC, okay, again in this question, it's fine. But here we can just assume that O is our center. Yeah, it's not like guaranteed, but these are just, they're not like examination questions, so they didn't specify, but we'll go through that. That's another concept that we'll discuss. Again, this topic is like a big topic. It's another concept we're going to discuss when we do a more complicated question is always do not assume that O or another angle that looks like it's the center. Don't always assume that it's the center. Make sure that you are definitely sure that it's the center. It's given in the question, or something about some information is given about the question that indicates it's the center, but please do not always just assume that everything or every coordinate that appears to be in the center of the circle is the center, right? Oftentimes it's not the center, and that's part of the trick of the question. Okay, so let's have a look at this. It says in circle O with diameter AC. So again, I'm just telling you in this one, you have to assume that O is the diameter. This is not an examination question, so they didn't specify. But in the exam or in any proper question that you do, it will have to be specified some way or another, implied, directly, indirectly, that is the center. Okay, so yes, diameter AC, DC is equal to AD. So that's not there, so we can put it. It says that DC is equal to AD. So automatically, I am seeing a triangle. I'm seeing this triangle, okay, with equal sides. I'm seeing an isosceles triangle, okay, so I'm seeing equal angles, okay. B2 is equal to 56. B2 is equal to 56. B2 is here. And this guy is equal to 56 degrees. Determine the size of DAB. DAB. So they want this whole thing. Okay, so that's how you start your question, right? All the information that's in the written, you put it inside of the diagram. The key thing also is to understand which angle are they looking for. So yes, you can work with what you have, but sometimes when the question is confusing, it's even hard to work with what you have. So you'll see again when we do difficult examples. So that's why we're definitely going to have another lesson on this. You can sometimes work backwards. Okay, you want to work backwards, like what angle do they want you to calculate? Work backwards from that angle to see how can you get that angle? Okay, it will make more sense when we do an example. Okay, so here it's a lot easier to start with information that we actually have. Okay, so I'm sure you guys have been looking at it, but I'm going to give you guys another few seconds to just look at it and actually talk to me. Give me some suggestions. What can we do? What angle is equal to what? Because of what reason? Okay, just keep in mind also, we have a cyclic quadrilateral. ABCD is a cyclic quadrilateral, right? Just a hint, just a by the way. I'm not going to be in the exam to tell you that, but I'm telling you now. Okay, brilliant. We have that angle B is equal to 90. So that's also one of the things. So yeah, I'm going to work really hard to try and create some summary notes for you guys. Just like a different, like a more structured approach to every single question, right? To help you not forget anything in a Euclidean question. Okay, some notes as well as we'll do a lesson. I think with this section, it's really important to do questions with you guys and show you how you should be approaching questions. Okay, like hard questions. Okay, so yes, the first thing is the diameter thing. Okay, diameter, what is this? Okay, any angle subtended by the diameter is equal to 90. So whenever you have the diameter, you look out for if there's an angle subtended by it. So this is equal to 90. Okay. One second, I'm going to take down a note. Um, okay. Okay. So where were we? Yes, we had that B is equal to 90. Okay, so I'm going to mention something also which we'll work with in difficult questions as well. You can also potentially, what you can do in your exam, right? You can solve the entire question using the diagram without writing anything. So solve the entire question in the diagram and then thereafter go and write everything out in your answer, right? That's also an option, provided you don't forget how you proved it. Okay, that's just sometimes an important thing, that you might forget how you proved it and then you don't know what to write. Okay, so but it's an option, right? If you prefer that, you can work with the diagram, like work with all the angles, do all the theorems that you can see, and then you eventually prove it, and then you write it all down, right? So that's what we're going to do here. Angle B is equal to 90 angles in a semicircle. Then B1 is equal to 34. D is equal to B. Okay, so multiple things I've got, right? So by the way, angle diameter AC subtends not just D, okay, which we've shown as 90. Diameter AC, sorry, also subtends B. So we could also say that angle B is equal to 90 for the exact same reason as the first, right? Our reason here is actually, we'll write it down, angles in a semicircle, right? It's just an angle subtended by the diameter. So that's the first reason we could use. We could also say that D is equal to B because of opposite angles in a cyclic quadrilateral, right? A, B, C, D is a cyclic quadrilateral. D and B are opposite to one another. So therefore, they are equal, okay? Okay, then the student says that this angle here is equal to 32, okay? That's 34, sorry, that's correct. Okay, the reason for that is because the entire angle B is equal to 90. So the fact that we have B2 as 56, the other part needs to make 56 plus something to give us 90. So 32 plus 56 will give us 90. You can say 90 minus 56. When we write it down, we'll choose what to write and it will make sense there. So therefore, we also have B1. B1 is 32. Okay, what else do we have? Any other ideas? Okay, remember the thing we went through in the previous question. What was it? Always remember your radii. B1 is equal to A2. B1 is equal to A2. Okay, fantastic. Okay, correct and incorrect. Okay, so the learner says that B1 is equal to A2, which is 100% correct. 32. But then their reason for that is radii. Can someone tell me why is that incorrect and what steps do we need to follow to get to radii? So B1 is definitely equal to A2, but why is that? Why is the reason incorrect? Specifically for saying that your reason is radii, why is that incorrect? Can someone tell me? Explain to me. There's a step we're missing before we can just say these are equal. Okay, that is correct. So it is angles opposite equal sides, right? So first, actually, we have to prove that, or we have to state this is a reason. Radii is a reason. It's a reason for what though? It's a reason for AO being equal to OB, right? Remember, it's not just like a thing that, okay, OA is equal to OB and you don't have to say the reason. You have to say it explicitly. You have to mention it, right? Yes, it's a radii and it's obvious that it's equal, but you still have to mention it, right? So you have to say that angle OA is equal to angle OB, and the reason for that is radii. Okay, so OA is equal to OB, radii. Thereafter, you can say that angle A2 is equal to angle B1, or the other way around, doesn't really matter, right? Which is equal to 32. And for that, now, this your reason is going to be the reason that the person gave me. Angles opposite equal sides. I hope that this makes sense. Okay, so just be aware of that, right? I hope that everyone understands that. Okay, so yes, that's correct. So now we have a part of the angle that we want to solve, right? Always keeping in mind we want to solve for what? DAB. Okay, this angle basically. So we have a part of it. Okay, anything else? What else can we work with here? Okay, so far we have this, and this is all correct. O2 will be equal to 106. Yes, correct. So we can complete this triangle in OAB. Okay, and someone says C2 we can work with. So we can complete this triangle in triangle OAB. Okay, and we can do what? We can use sum of angles in a triangle to say that this is 180 minus 2 times 32, or just 180 minus 32 minus 32. And we get 116. Okay, then someone else says we can use this triangle. Okay, and we can also use the radii. So angle C2 is equal to 56. Okay, then someone else says this is great. Angle A1 is equal to angle C1 because of the same reason, right? The angles opposite equal sides. So again, we're not writing any reasons now. So yeah, we can take the shortcut and just like make them equal. Maybe we say this is y, whatever you wanna do, right? But for now, we just solving in terms of the diagram. All the reasons we'll write later. Then we can get O1 by saying that 180 minus 116 is angles on a straight line. So there's two ways in which we can get O1. We can either do sum of angles in this triangle, or alternatively, we can even do it on a straight line, right? Angles on a straight line, like that. Okay, and okay, so yes, we can say 180 minus that to give us this. Okay, and this is gonna be 180 minus 116 is 64. Okay, we could have also said 180 minus 56 minus 56. We'd have also got 64. Now we have O1. Okay, but yeah, okay, but now you see the main thing now we need to solve for in order to solve our answer is for A1. So how do we solve for A1? Okay, so we got all of these angles inside this other triangle. So it's going to be 134 degrees, not 32. You are probably correct. Let's just see. No, it's 32, I believe. No, you're right. It's 34. Sorry. This is wrong, and this is wrong. So this should be 34. And there should be 116 minus 4, which is 112. And there should be 64 plus 2, which is 66. I think we are correct now. Let's just double check. And 18, 68, sorry. Okay, now it should be all correct. Can we do 180 minus 90 divided by 2, angles opposite equal sides? Okay, brilliant. So in angle DAC, get all of this. In angle DAC, okay, we can work with radii as well, where AD is equal to DC, okay, these are equal, so the angles opposite each other would also be equal. So angle C would be equal to angle A, and then we could get the value of A1, because we can simply say 180 minus 90 divided by 2. Okay, let's put all of that into writing. So we're going to start off with, I'm not going to put everything, right? I'm just going to put the things that we need. So we needed to solve for A2, okay? We had the value of that. So what I'm going to first start by saying is, I'm going to say that angle B is equal to 90. And the reason for that is angle in semicircle. Okay. Then I'm going to say angle B2 is equal to 56 given. This is not too necessary, I wouldn't think. Okay. Then we can say that angle B is equal to B1 plus B2. Okay, there's no reason for that. That's just because B1 and B2 make up B. Okay, so because of this, we can say therefore angle B1 is equal to 90 minus 56, which is equal to 34 degrees. So now we know the value of angle B1. Since we know the value of angle B1, we can move on to this thing, right? To use this isosceles triangle, remember we have to explicitly mention which sides are equal, the reason they're equal, and then say that those opposite angles are equal. So I have to say that OA is equal to OB radii. Okay. And then from that, we can conclude, therefore, that angle A2 is equal to angle B1, which are both now equal to 34 degrees. Okay. And the reason for that is what? The reason for that is angles opposite equal sides. Okay. Thereafter, okay, there's no need to even prove for O2, nor is there need to prove for O1 or any of that. We can immediately move straight to this. So there's multiple reasons to work with D, remember, but I'm just going to say angle D is equal to 90 again for the same first reason, angle in semicircle, right? Okay, angle D is equal to 90, angles in semicircle. Then I'm going to use DC and DA, AD, DC. I'm going to say that AD is equal to DC. This is not radii, by the way. This was given to us that they are equal. Please keep that in mind. Those are not radii. This is given to us in the question, so we say given. Okay, so that's given. So we can conclude from that therefore angle A1 is equal to angle C1. Angle A1 is equal to angle C1. Okay, and the reason for this again is angles opposite equal sides. Okay, angles opposite equal sides. Right, then we can solve for it. So you can either say in triangle ADC, that's not compulsory. But what I'm going to say is angle. I'm going to say that angle D, what's the best way to put this? Angle D plus angle C plus angle A1 is equal to 180. Let's just draw a line, why not? Angle D plus angle C1 plus angle A1 is equal to 180 degrees. Okay, you don't have to mention this again. You could also just take the shortcut to say that angle A1, which is the one we want to solve for, is equal to 180 degrees. minus angle C1, and we actually divide that by 2 if you really want to take the full shortcut, and then still give the reason, right? But here I'm doing it the long way. I'm going to say sum of angles in triangle. Okay. Hope that's making sense to everyone. And remember, this is like y. If one is y, they both y. Okay, so if you want to assign the variable y to it, that also is fine, right? So that it makes more sense. So I'm going to say let C1, which is equal to, you don't have to do this, but I'm just doing it so that you can see how we get the shortcut. Let them both equal to y. Okay, and in this case, okay, you're going to have, if you want to solve for a1, why do I want to solve for a1? I want to solve for a1 so that I can get the whole of a. I have a part of a, now I just need the other part of a, which is a1. So that's why I'm solving for a1. So a1 is going to be equal to 180 degrees, right? If I take these two over, it becomes minus c1 minus d1, but it's going to become what? Minus y minus y. Minus d as well, sorry. That's the one we're missing. So minus 90 minus y minus y. Just trying to think. What's the point of what we're doing? This is not right. Sorry. Just minus y, I think. Then we should, how can you deduce this? 180 minus 2y, 180 minus 90 gives you 90. And then 90 plus 2y should be equal to 180. Yeah, I think, sorry, we should do it this way. Okay, so 90 plus y, which is 90 plus y is equal to 180. Okay, yeah, this is the best way to do it. So 2y is equal to 180 minus 90, which is 90. I take this over to that side. Okay, and then I can say y is equal to 45. It's like dividing both sides by 2. Okay, so that's the long way of doing it. The way of representing all of this, okay, quickly. Okay, I just wanted to explain that. Cheers. Okay, you can simply just say that a1, okay, is going to be equal to 180 degrees minus angle d, which is 90. Let's put it here. D, okay, divided by 2. Okay, because when you subtract d, right, I get 180 degrees minus d. Okay, I would get the value. So I subtract that. It's going to give me the sum of these two. Okay, if I subtract one angle, this is going to be equal to the sum of A1 plus C1. And A1 and C1 are equal. Okay, so therefore, when you get that value A1 plus C1, you can simply divide it by 2. Okay, so all of that you can represent by this. And that's perfectly fine. And your reason again for that is going to be the same reason. Sum of angles in a triangle. So if you name the angles in the exam, do they allow it? Yes, most definitely. If you say let C1 is equal to A1 is equal to Y, that's most definitely fine. Provided that you don't just not mention it. Like you can't just say y is equal to 50 and then in the diagram there's no y. But if you mention this, let C1 and A1 equal to y, they're not going to have a problem with that. That is most definitely okay. Okay, so yeah, just keep that in mind. Okay, so therefore we've proven that y is equal to 45 and y is A1 because we said let A1 is equal to, so that you can therefore conclude, okay, A1 is equal to 45. Okay, and then therefore angle A, what was the angle they wanted us to solve for? Angle DAB is equal to angle A1 plus angle A2, which is equal to 45 plus 34. So the answer is 79. Yeah. The answer is 79. Okay, a simple diagram, that's the amount of different theorems that we can use. Okay. Okay, so Let me just think. Okay. So look, I don't like taking shortcuts. I know that things take long, but I like to go slow with you guys and make sure that I explain everything. Okay. So I'll definitely want to do this question, right? We can do this question. We will do this question. And then we need to move on to this, which is really important, right? Hints when answering geometric questions. Okay. I'm going to add on to this probably like some of my own things, but like these are things that you'll say I have mentioned like previously, like probably at least a few times, right? Maybe we haven't gone through it explicitly, but what I want to do is I want to work through this with you guys, right? Like the hints, right? Important things that you need to keep in mind when answering a Euclidean question, like very important things that you need to keep in mind. Okay. Also, like what I'll do is I will create a list of things that you need to be aware of, like just like a reminder that maybe we can create an acronym for us to say, okay, here's our acronym. This is what each thing stands for. We need to remember parallel lines. We need to remember this. We need to remember that, right? So just in case you're stuck in a question, you can always go through that and then try and go forward from a question there. Just things like, okay, this is also important, proving for cyclic quadrilateral, which is very common. And the last point, right? Do not use the properties of said cyclic quadrilateral to prove angles using a different method, then conclude that it's a cyclic quad. Like all of these things, these are concepts, they are like theoretical concepts, important notes and hints that you need to remember. But the most important thing is actually practically doing this, like getting the practicality of these statements. Like for example, the second point says never assume anything. If not given or marked on a diagram, it's not true unless proven. Okay, so that's like something important where we need to go through an example where I can show you that the question is trying to trick you into making you assume that something is the center, but it's not the center, right? So that's how I want to do it with you guys, like go through each of these hints or things that you need to look out for, and then actually go through an example where I can show you this is what you need to look out for. Okay, so it's a long process, right? Let's just see. Maybe we might not do it now. Maybe we'll save that for the holidays. Okay. I know you guys are writing exams. Don't come at me. Okay. Time is limited. Time is sacred. Okay. So maybe we'll like save that for I'll decide in this week, right? Maybe we save that for like the holiday program where we just do a bunch of revision and then we can really sit with that. And then in the meantime, we can just move on to another topic and try and get at least one more topic done before you guys write. Okay. But yeah, we'll get there. Okay. So before you guys go, sorry, I kept you guys a little bit extra, but nevertheless, um, tell me, just type in chat Q&A, wherever, YouTube chat. Please just tell me in chat, what is the date that you guys are writing maths? Your maths grade 11 June exam. When are you writing it? What's the date? Obviously, different people have different dates, so that's why I'm asking. Just let me know. Is that your paper 2? Is on the 2nd of June? Is that your paper 2 or your paper 1? Okay, so quite a few of you are writing on 12. Okay, then paper 1's 9th, 1st, and okay. Okay, that's fine. So basically we have like maybe let's just see 2 more weeks of lessons before we get to paper 2 exam. Okay. Okay, so it seems like mostly we have around 2 more weeks before we get to your guys' paper, which is fine. So let me just see. What I'm probably going to decide on is moving over to the next topic, and then we can come back to like these in the holidays. All right. So you guys, I'll send you guys this document. Please do go through it, like attempt this question, read through these notes, try and understand them, the hints, right? Look at these notes, try and go through them, try and attempt this question, and then message me. There's also a past paper here, which I put, you can attempt it. I'll put the memo for it as well. Right. Message me to ask if you guys have any questions. I'm also currently busy with exams, so it's a bit hectic, but I do try my best to respond to everyone. But yeah, that's what I would recommend for now. That's the plan. I hope you guys understand and cool with the plan. And yeah, the objective is to hopefully like by the end of the year going into grade 12, kind of get us into the system of like doing well in Euclidean and understanding everything, right? It's not like a 1-day process or 1-week process or a 3-week process. Sometimes it can take time. Okay. So just bear with me, bear with yourself, have patience with yourself. If you're struggling with Euclidean, we will get there. Okay, cool. So let us end it there. I'll leave it open for the next minute or so to see if anyone else has any questions. Please feel free to ask your questions. But if not, you are free to leave, and I will see you guys next week then. Thank you guys so much for joining. Again, it's going to be open for the next minute or so, and then I'll automatically just end it. But yeah, for those of you who need to leave, thank you guys so much for joining. I will see you guys next week. Jazakallah khair. Assalamu alaikum and goodbye.